In this lesson, we are going to solve systems of equations by elimination. Our objectives are to identify which systems we should solve by elimination and then to be able to solve them. First of all, we need to have our like terms lined up. In other words, when we're solving the equation, we need the x's to be lined up vertically on top of one another, the y's lined up, and our constant numbers lined up on the same side of the equal sign. This is a non-example. We do have the x's lined up, but in this case, for the top equation, the y is on the other side of the equal sign. We also need one pair of variable to be the opposite. For example, 3x and a negative 3x are opposites of one another because our goal will be to have that be a sum of 0. We will be able to make them opposite by using multiplication and equivalent expressions. Let's begin by doing some examples. In this case, we want to check first that our variables are lined up vertically. So we have the 5x on top of the 3x, negative 6y on top of the 6y, the equal signs, and then our numbers on the other side lined up vertically. To do the process of elimination, we're going to add the two equations together vertically. But we also want to check to make sure that one of the variables is the exact opposite of the other. We do have negative 6y and positive 6y. So we're going to simply add the two equations together. So you'll put a big plus sign and line underneath and add them vertically. 5x plus 3x, combining like terms, we have 8x. Negative 6y and positive 6y has a sum of 0. Our goal is to have one of the variables have a sum of 0, so our resulting equation, 8x equals 16, is in one variable. We can solve for x by dividing both sides by 8. X is equal to 2. That is the first part of my ordered pair for my solution. Now we're going to take the 2 and we're going to substitute it back into one of the equations, doesn't matter which one, and we're going to solve now for y. So I'm going to take out the x and substitute in 2. 5 times 2 is 10. I'm now going to subtract 10 from both sides. My goal now is to get the y by itself. So I have negative 6y is equal to negative 42. And I'm going to divide both sides by negative 6. So y is equal to 7. That is the other part of my ordered pair, and this is the solution to my system. This is the point at which these two lines would intersect if we were to graph them on the coordinate plane. To be sure this is correct, we plug it into the other equation. 3 times 2 is 6. 6 times 7 is 42, and 42 plus 6 is 48. In our next example, we want to make sure that the variables are lined up vertically. We have the a's on top of each other, the b's, the equal signs, and the numbers. So we're going to add them together. We also want to make sure that one of the variables is the exact opposite. I have a positive a and a negative a. Our goal when we add is for one of the variables to have a sum of 0, a and negative a is 0. Then we combine like terms, negative b and a negative 2b would be negative 3b equals 8 minus 5, which is 3. And we solve by dividing both sides by negative 3. So b is equal to negative 1. That is the second part of my ordered pair. Since I'm using a and b, we write our ordered pair in alphabetical order. Now I'm going to take the negative 1 and substitute it into the equation to find my a. So I have a minus negative 1 equals 8. Remember that minus a negative is plus, and I'm going to subtract 1 from both sides, so A is equal to 7. That is the other part of my ordered pair. Now let's put that into the other equation and make sure it works. So I have negative, and I put in a 7, and then I have negative 2 times negative 1 would be positive 2. So negative 7 plus 2 would equal negative 5. It is a solution to our system. And remember, if we were to graph this, this is the point on the coordinate plane where my two lines would intersect. Now let's take a look at the next example. We have our m's lined up, our t's lined up, equals, and our numbers lined up. But we don't have either of the variables being opposite. Well, there's a couple of ways that we could tackle this. We could get the m's to be opposite, and to do that, we could multiply the entire equation by negative 5. Or I could get the t's to be opposite by multiplying both the entire equation by negative 1. Either one would work. I'm going to multiply the entire equation by negative 5. When you do this, it does not change the value of the equation. It simply changes what it looks like. What that will do for me is it will have now my m's being opposite. So when I add them together, they will have a sum of 0. And I will have an equation that is in one variable that I can solve. I rewrote my other equation directly below, and now I'm going to add the two together. 5m and a negative 5m is 0. Negative 5t plus t is negative 4t. And that equals negative 30 plus 14 is negative 16. I'm going to divide both sides by negative 4. So t is equal to 4. My two variables are m and t, so putting them in alphabetical order, that is part of my ordered pair. Now I'm going to take the 4 and I'm going to plug it into one of the equations. Doesn't matter which one. I'm just going to do the second one this time. So I have 5m plus 4 equals 14. Substituting the 4 for t, I'm going to subtract 4 from both sides so that I can solve for m. So 5m equals 10. I'm going to divide both sides by 5. M is equal to 2. That's the other part of my ordered pair, which is the solution to my system. I can take the 2 and the 4 and plug it into the top equation to check. 2 plus 4 equals 6. The point is correct. In my next example, I do have my variables lined up. I have my 8x and 3x, my 5y and negative 2y, my equals, my 6 and my 10. I need to get one of my variables to be the exact opposite. So what we're looking for probably is the least common multiple, either for 8 and 3 or 5 and 2. And we also need one of them to be positive and one of them to be negative. Well, I'm going to just do the y's. 5 and 2. Common multiple is 10. So in order to get 5 to be the number 10, I'm going to multiply by 2. And in order to get the negative 2 to be a negative 10, I'm going to multiply by 5. And then they will be opposites of one another. Make sure you're multiplying the entire equation. So when I distribute the 2, I get 16x plus 10y equals 12. And when I distribute the 5, I have 15x minus 10y equals 50. Now my y's are opposites of one another. and I can add the two equations together. (16x plus 15x is 31x, 10 and negative 10y are 0, and 12 plus 50 is 62. So when I divide both sides by 31, x then is equal to 2. That's the first part of my ordered pair to find my solution. Now I'm going to substitute the 2 in for the x and finish solving. It doesn't matter which equation, I'm just going to pick the second one. 3 times 2 is 6. I'm going to subtract 6 from both sides. So I have negative 2y is equal to 4, and I'm going to divide both sides by negative 2. So y is equal to negative 2, and that's the second part of my point, which is my ordered pair, the solution to my system. Let's check to be sure in the top equation that that's correct. 8 times 2 is 16, 5 times 2 is negative 10, and 16 plus negative 10 is 6. That is correct. That is the solution to the system. In this example, we have the variables lined up. Notice the y's are on one side and the x's are on the other side of the equal sign, but that doesn't matter because they're lined up. We have a couple of choices. We could multiply the top or the bottom equation by negative 1, which would make the y's opposite, or we could multiply the entire top equation by 2, which would make the x's be the opposite. I'm going to multiply the top equation by negative 1. So I have negative y equals negative x minus 6, and I rewrite the bottom equation directly below. Now the y's are opposites of each other, and so we'll have a sum of 0. Negative y plus y is 0. Now we have to write the 0 this time because it's going to hold that place on the equation. Negative 1x minus 2x is negative 3x, and negative 6 minus 3 is negative 9. My goal is to get the x by itself, so I'm going to add 9 to both sides. So I have 9 equals negative 3x, and I'm going to divide both sides by negative 3. So negative 3 equals x. So negative 3 is the first part of my ordered pair, which is the solution to my system. Now I'm going to take the negative 3 and I'm going to plug it into one of the equations. Doesn't matter which one, I'm going to go with the second one. So I have y equals negative 2 times negative 3 minus 3. So I have y equals 6 minus 3, so y is equal to 3, which is the other part of my ordered pair, the solution to my system. This is the point at which my two lines would cross on the coordinate plane. Let's put it into the first example to make sure it also works. Negative 3 plus 6 is 3. Works there as well. Let's take a look at this example. If I want to get the x's after my variables I see they're lined up to be eliminated and become the opposite, I want to multiply it by negative 2. I'm just going to write it directly below this one. After I've distributed, I get negative 4x plus 6y equals negative 18. Now I have my x's being opposite of one another. So 4x and negative 4x is 0. Negative 6y plus 6y is 0. And 5 minus 18 is negative 13. In this situation, both of my variables dropped out. This should look familiar to you. We've had this situation before. 0 equals negative 13 is not true. That means there is no solution. And when we're solving a system of equations where there is no solution, that means that our lines are parallel. Last example. 4x, 12x, 5y, 15y equals 12 and a 36. They're lined up. Let's get rid of the x's. To make 4x be the opposite of 12x, we need it to be negative 12x. If I multiply by negative 3, I will have a negative 12. So let's distribute. Negative 3 times 4x is negative 12x. Negative 3 times 5y is negative 15y. And 12 times negative 3 is negative 36. Let's add the two equations together. 12x and negative 12x is 0. 15y and negative 15y is 0. 36 minus 36 is 0. Again, the variables have completely dropped out, and a situation you've seen before. Does 0 equal 0? Yes, that is true. That means we have infinite solutions. And if we were to take a look at the graph of this, that means that these are the same line. So in review, first we need the equation to line up with like terms. Then we need to make one pair of like terms opposite using multiplication. Add the two equations together and then solve for the remaining variable as well. Please be sure to complete the reflection.